Hello everyone, I'm Karthik Atmanathan. I'm a professor of practice here at IIT Madras, and prior to this I was Senior Vice President of E-Mobility at Ashok Leyland, and I'm trying to give you a perspective which is outside the vehicle. Most of the technical courses we will be focusing on the subsystems and the systems as well as the detailed engineering of the vehicle. I'm trying to give you a perspective which is a wider scope. So it won't be very deep, but it will cover a lot of areas to give you an idea about the market, the field, the EV penetration over the years, etc. So that's the objective. So I'm taking you through these 6 different topics. First we'll talk about the ecosystem, and then we'll talk about safety, which is very close to my heart. I always start with safety, but this time I thought I'll make it the second point. Then we will take a quick look at the taxonomy, the topology and the architecture and the various platforms for electric vehicles. We'll just talk about it, not really too much of technical details, because that would have been covered in the subjects, or they will get covered in the other subjects. And then how does EV penetration look in India? When is it transitioning? And after transitioning, how does it go up as a percentage of total number of vehicles sold? Also give you some insight into new technologies that are coming up. There are so many new technologies that are coming up that it's difficult to cover all of them. I've just selected a few, and I'll be happy to discuss details later on other technologies. And finally, what are the current challenges that the industry is facing, and also as employers of the students, what do they find is missing? Right. So this will give you a better perspective of how to go about it when we take it up with the industry. So the first one, the ecosystem. This is a classic representation. So if we see here, we first start with your generation right on top. So you've got either wind mills, or you've got power plants, or you've got your solar plants. So that goes on through the transmission at over long distances, the high voltage transmission, and then you go to the distribution lines, and then finally it goes to the charger through a substation, and then your vehicles get charged. So this is nothing new, all of us know this. Meanwhile, if you see the DISCOM and the value chain for the power supply, so you've got the smart charging option. So the distribution company sends the power to the charging operator or the households that are charging, and when the customer uses the charging service, you either have metered smart charging, or you have quite a few cases where the network provider adds further value by giving you online booking, etc. This is just starting off, not very common in India. Even though the companies that offer this are there, it is not very prevalent yet. What we are trying to highlight is the problem in these areas, right? So we have, if you look at the topmost thing which is flipping all the time, that exclamation, red exclamation mark, bottleneck on distribution lines and local transformers. See, most of the DISCOMs, companies which provide our electricity board, so to say. So most of these companies, they are hard pressed for cash. So they don't actually give you an infrastructure which is in line with most of the advanced countries. So what you have to do is, in quite a few cases, set up your own substation, and even for that the DISCOM insists that it should be done by them, and they don't have the cash flow, so they have to wait and place the order, tendering, etc. So the actual distribution lines and the local transformer, these are quite a big challenge for companies who are setting it up compared to other countries where it is privatized. The other one is the distribution line itself. When they step down power and they distribute it across locations, the level of load that they have planned is at a fairly low level. So there are quite a few cases where you are forced to take a separate 2 kV line or something and bring it all the way to your transformer, because such a line doesn't exist which can support the additional load. So this is another problem. And of course finally, because most places it is state government controlled, you don't have the freedom of metering and selling power that easily. Of course, there's a Ministry of Power guideline which says that it is now deemed as a service and it is not a sale. So, you are not selling power, you are only providing service is the interpretation, so that more of the EV ecosystem can be supported for power supply. So, quite a few challenges in the ecosystem in and around the electricity distribution. Tech is there, but it is not apparent in day-to-day use. So, this is one area. The other one, I just wanted you to be aware of the various technology readiness levels, because this e-mobility is an evolving scenario. It is not static. If you take ICE engines or if you take a mechanical gearbox, most of the tech is mature and you just do a little bit of changes or you do product development. The fundamental engineering is all done, mostly done, and it is a mature technology. But in e-mobility, there is a lot of day-to-day new research happening because it's a brand new area. So, it is not something which is mature. So, that is where people like CB, even IIT Madras, etc., they play a pivotal role because they try to bridge the gap between the evolving technologies, continuously evolving technology, and they productize it and show industry and users how to productize things as they keep coming up. It is a very vital role to play in this thing. Of course, if you catch the industry after 15 years or 20 years, this will also be a mature industry, but right now it is an evolving industry, right. So, you need to understand these technology readiness levels. So, the first one is the basic research, next one is applied research, then you have critical function, and then you have the alpha protos, beta protos, then you start looking at the actual material production of testable prototypes, and you start doing the product validation and the reliability testing. Pilot production, you will do more of reliability testing at that level, and then you go into techno-economic evaluation in the market. So, finally, nothing works if it does not make money for everybody in the value chain. Only then it works. Otherwise, of course, there are exceptions like healthcare and public transportation, etc. But in most cases, if the consumer does not benefit and his supplier does not benefit and his supplier does not benefit, etc., if the value chain is not making profits, nothing can last. So, the techno-economic validation is very important before you get into production, and then finally you do the production. And one lovely part about e-mobility is, in India, this is the first time where we can actually do work across the levels. Otherwise, in most cases, we start at TRL 6 or TRL 7. But this time in e-mobility, India has the potential and it is already doing work in TRL 1 all the way up to TRL 9. We need to do much more than what we are doing, and we need to be better coordinated, but it is happening quite well. Yeah. So, this is something which you need to keep in your mind. It is important that you understand the physical ecosystem and the technology ecosystem, how to apply this onto the evolving e-mobility ecosystem. I hope this is kind of clear. We will be happy to discuss it later. Next, we come to safety. There are three types of safety which are relevant to e-mobility, right. So, the first one is the safety of the product itself. The product that you make, it has to be a safe product for use. So, you have various things. You have an emergency cutoff switch in vehicles, especially in the high voltage, high energy vehicles like a truck or a bus. If you look at a two-wheeler, probably it's got about 1.5 kilowatt hour of battery, and it's I don't know, 24 volt system or 48 maximum, going up to 48 volts for the fancy products. But if you look at a LCV or a car, a powerful car, it is already 330 volts DC. It's fatal. On top of that, he is probably sitting on about 30 kilowatt hours of energy. And you go to buses and trucks, you are dealing with 700, 800 volts DC, and you are dealing with maybe 300 kilowatt hours of energy. So, this is like really high potential. It's like a diesel or a petrol tank. It's as dangerous as that. So, you need an emergency cutoff switch on the vehicle. You need your wiring and aggregates to be rated for high voltage applications. So, you cannot there are certain norms that you follow, the way the terminals are terminated, so to say, and then the way it is bent around. There are norms for these things so that there is no abrasion related or vibration related failure. So that's an important point. Battery fires, we need to understand how to install a safe fire detection system inside the vehicle and a fire suppression system. Here, unlike your regular diesel buses or petrol cars, you have different types of battery fires. So you need to be addressing the fire suppression with the specific chemicals which are pumped to suppress the fire. So it's an important part of product design and product development. So it is important, what I told you about the layout and the terminations of the various connectors and the cables, etc. These are important safety practices. So there are quite a few safety practices on the product which we have to adopt. Then we talk about personal safety. Personal safety is the safety of the people who work on the product. They are either manufacturing it, or they are prototyping it, or they are testing it, right, or they are maintaining it. So these are all companies from the automotive company, people from the automotive company, and they need to be protected. So we need to give them correct gear. So during assembly of vehicles, there are a lot of protocols that have to be implemented in the production line, and in a few cases the product is designed so that production safety is possible. So this is an important angle. While maintaining vehicles, once again we try to design the layout and the cabling so that when the maintenance engineer goes, his risks are already minimized. In spite of that, he needs to take a lot of care. While driving the vehicle, the driver has to be aware of the safety procedures in case there is a fire or there is an accident. It's important. One important part which is hidden behind all these in personal safety are the tools and the equipment that they deploy, right. So you have extremely special equipment for high voltage assembly lines. You have safety mats, you have the kind of working gloves which are higher grade, and you also have a fair number of tools which have much higher levels of insulation when you are handling the high voltage system. Public safety, most important, because these vehicles are going out in the public, they are on the road. So nobody understands public safety for electric vehicles right now. So it's important that the government, this is a government move, government has to do most of this. So first responders, people in fire stations, they should know how to treat a EV battery fire. They cannot treat it the same way as a wood fire or a building fire or a diesel fire or a petrol fire. It's a different way. They should understand that if you put the fire off and you walk away, it will come back again. That's how much of energy that's getting released from inside. So they have to dunk the battery in water, right, so that it stays and bubbles and boils and then it spends its energy. It doesn't stop spending the energy. So you have to keep it safe inside that. The police have to know, because if there's an accident, they have to keep people 15 feet away and make sure that nobody is coming here, because these are fires which look very ordinary and then suddenly they become extremely volatile. It's like an explosion once again. The hospitals need to know how to treat these burns, or the high voltage people who have been affected by high voltage. So the emergency wards in the hospitals, they need to be trained as well. So these are all first responders if there is a accident. Public awareness campaigns, we have to conduct a lot of public awareness campaigns where people understand that these are fairly risky items. And passenger safety, the passenger, how he uses the vehicle, especially the private passenger vehicles, they need to be careful about how they go about it. And public safety, there are quite a few factors that come in, and we have to train and we have to put up posters everywhere, and we need a lot more awareness, right. So next we come to the taxonomy and the topology, right. So this is broadly the taxonomy. I'm not covering close to about 30% here. This is just to give you an idea, right. So three major areas: charging infrastructure, energy storage system, and the propulsion. These are the three big areas in the electric vehicle. And in charging infrastructure, you must have seen the plug-in chargers already. You must have even got into the engineering of those things. But you also have induction chargers. And here you have both static and dynamic. So induction chargers are those chargers which are on the floor typically, and the pad is there, and the vehicle goes and stops on top of that, and through induction you charge the battery, right. It's fairly safe, and it is extremely convenient, because if I don't have space for a charger and cable to come, etc., this is a nice arrangement to have. There is no cable and no connector, nothing. So I just go and park. So it's, if you have a parking slot, you can charge. You don't need a separate space for the charger, but it also comes with its own disadvantages, right. So you have to make your choices right, but induction, now of late you have a couple of companies, one in Korea and one in Israel, which have started offering dynamic inductive charging. So you have the inductive charging systems inlaid into the road, and you go onto that lane, it charges your vehicle while you are driving over it, right. So there is no contact with the charging system, it is just induction. So this dynamic thing is just started. I think they've piloted in Italy, Israel of course. I think there was a pilot which was being done in Germany. So they are trying to do a few pilots, evolving technology, very interesting, very promising, and this is something which will be very nice for India, because you don't have anything above the ground. So in case of accidents or poor quality driving or compliance. Overhead charging, you've heard of it. One is of course the fixed pantograph type of thing. So you go park your bus. This is predominantly used in buses today, but I don't see why it won't come to trucks also later. But it's definitely not something which can come for cars. You can't have something on top of the car. So overhead charging, buses and trucks, you have a pantograph which comes and charges the bus or the truck, and it goes back. You can charge at much higher kilowatts compared to the plug-in charging, and the pantograph can be on the truck or bus and go up, or it can be in the infrastructure and it can come down onto the bus. Both options are available. And then you have the overhead dynamic charging, which once again I think Siemens has developed the system. They are running 3 pilots as of today. One is in California, one is in Sweden, and one is in Frankfurt. So these 3 pilots are running, where you have about 2 kilometers of the overhead line, and then the truck comes onto that lane and it takes the thing while it is driving. So it's a dynamic overhead charger. So broadly, these are the charging infrastructure options. And in energy storage, you all know about batteries. I don't think I'll go too much into it, but you have different types of batteries. I hope you're aware of it. So you've got your old-fashioned lead acid, and then you've got nickel cadmium, nickel metal hydride. These have all been there for some time, and now you have the various lithium ion batteries, whether it is LFP or NMC or LTO. Now you have polymer batteries coming in, which is deemed safer, and you have solid state coming in as well. So you've got the batteries here. Metal air batteries are evolving. In fact, IIT Madras is doing quite a lot of research here. There are quite, I think, 3 or 4 streams which are actually working on this. Very, very promising technology. You have fuel cells which uses hydrogen as a storage, and you process hydrogen to get water. And you have ultra capacitors. Ultra capacitors are basically very fast charging batteries, but they cannot store much energy. They are very big. The energy density is very low. And you have propulsions in the EV. Basically, you either have a pure electric vehicle and you charge the battery and drive the motor, or you have range extenders, things like fuel cells or micro gas turbines or other devices which will generate energy and pump it into the battery while the vehicle is running. Hybrids, parallel hybrids, series hybrids and combinations, not of much interest today because battery prices have come down. Hybrids are slowly becoming less favored because they are no longer a nice interim transition solution. It is still there, it is still useful in its own way in certain segments, but not across areas. So I've brought a vehicle platform which is a bus, right? It was easiest for me because I am from Ashok Leyland. If you see here, you've got essentially all the relevant systems. So you've got a body control unit, that is the body control unit there, and you've got a vehicle controller here. The vehicle controller is basically the master, and the controls developed the algorithm, and the software there is probably the most critical one in any electric vehicle. And then you've got your subsystems, right, auxiliary drives. One is for the HVAC, the air conditioning, second is for the steering, and the third is for the compressor, because it's these, if you see steering pump and compressor typically is all these three are connected to the engine in a ICE vehicle. Here you don't have the engine and you can't connect things to a motor, it's not very efficient. So you have dedicated motors with controllers and inverters just for these, each of these subsystems, and you have to manage them as well. The vehicle controller controls them. And then you have the big daddy, the traction inverter and the traction motor, right. So that is the one which is going to give you it's going to decide the level of performance. And having gotten the traction motor, depending on application, the weight, the motor's torque and the vehicle's torque requirement or GVW, you might have to gear it, and you might have to put in a transmission, predominantly automatic transmission. And you've got your lithium batteries here, either NMC or LFP, it depends a lot on what the financials are, and you might have a fuel cell controller and a fuel cell to keep pumping energy into the battery, right. So that's one part. And the charge controller. Finally, you've got your charge controller, and it will be able to handle AC charging, DC charging as well as flash charging. Flash charging is the charging which you do at very, very high voltages and wattages, a lot of current. So you can pump much more energy into the battery than you usually can. So the idea is an architecture needs preferably to permit all types of energy management, right. Whether you are fast charging or flash charging or swapping the battery, you need an architecture which will allow this. So you need to be a little modular in the approach. The battery itself is better to be modular, so that if the customer wants double the capacity or range, you can give him double the number of batteries if he's got the need for it. And wherever it is possible, it's good to commonize the aggregates. These are the initial stages of e-mobility. So you can't have very specialized supply chains for each segment. You need to have as much of commonized aggregates as possible, so that you can leverage the volume and use the supply chain more productively. In the right bottom, if you see, this is a Ashok Leyland strategy, but what we have done is we have created a modular cradle. Now this cradle can go into about 4 or 5 different types of buses. It's the same electric set of aggregates. So they will go and they will fit into the vehicle, and so you have a modularized solution or system. So vehicle topologies, if you look at the motor location, you have a central motor with a propeller shaft which runs the rear axle. Second, you have an e-axle, and the motor goes and sits on the axle's differential itself, and it drives, it's more efficient, you save about 4-5% of the energy. You have e-axles with multiple motors, so sometimes the axle has 2 motors which are driving different sides of the axle, but it's still part of the axle. And then you have hub motors which go right into the wheel, and you have in-wheel and hub wheel motors. Modular batteries, I told you about them being in different locations. And of late, there are quite a few commercial vehicles which are coming with hybrid energy storage solutions. So some of them have ultra capacitors, some of them have fuel cells, but you can combine the battery and the ultra capacitor to balance the high power density and high energy density requirements. So the ultra capacitor charges faster, it can discharge faster, but it can't hold much energy and it cannot hold it for a period of time. The battery, it charges much slower than an ultra capacitor, it discharges also that much slower. So power density is low, but you can actually use it for storing much more energy and for a longer period of time for the same size. We now come to EV penetration, and I think we'll take this up in the second session. Thank you very much.